This is the notes for lesson 3.3. There's no notes to take. You just need to watch. It's finding secant line limits graphically. So we've talked about a secant line is this orange dashed line where it's touching our function in two spots. So to actually create something linear that we could find the slope of, and that's also called finding the average rate of change. Because you can see our black function here is curved. And so that's a lot of calculus, is finding the slope of a curved line. And so what the directions say is to move the blue dot as close as possible to the yellow dot at x equals -2. Zoom in to get the blue dot as close as possible to the yellow dot without touching it. So this is just kind of an exploration activity where you're going to take the blue dot, because right now you can see the slope is this. And we're getting closer and closer to the yellow dot, which makes this h value get smaller or closer to 0. So anywhere close is fine. Hit zoom in. It'll zoom the graph in kind of like we do on Desmos, and now you can see that we're counting by something smaller, and we need to get the blue dot again as close to the yellow as we can without touching. Now we're 1/100th of the way apart, and then we got to zoom in again. Now I'm 1,000th of the way, or a distance apart from the yellow dot, and then one more time as close as you can and hit finish. So what we did is we zoomed in and got the yellow dot so close to the blue that we have a really good approximation of what the slope of that line is right there. And we're going to round. So as soon as you see a bunch of 9s or a bunch of 0s, that means this is going to round up. So let's make this 3.84. Don't worry too much about this formula here, but it does come back to this y2 minus y1 over x2 minus x1. It's just a way to calculate slope that we'll get into later. And so you can see here as the distance gets closer and closer to the yellow. Let's do one more. Hold on. Whoop, there we go. Okay, so let's go this way. It says move the blue dot as close to the yellow at x equals -3. So what I want you to notice here is that this graph has this little corner here, or sometimes they call it a cusp, like an edge here. What happens when I move the blue dot closer from the right? See how the slope of my orange line is positive? Right now it's like 2.18. I just want to show you that if I were to come in from the left and I move closer, see how now my secant line is actually negative slope? So I don't have the same slope coming from the right as I do from the left. So that already tells me it's D&E, but I still have to do the zooming in so that I can submit my answer. So we just want to come as close as we can to the yellow. And do it again. One more time. Oh, one more time, sorry. And we would have 2.2, but again, it's not the same as coming from the other way. So we want to put D and E. And you can watch here. Here's our slope. Positive 2.2. 2.1, no, yeah, 2.2, sorry. And then coming from the left is a negative something. Two totally different slopes mean it does not exist.